In this assignment, we get a lot of mixed practice. So here we want to show that there's an x-intercept in the interval. Well, we know polynomial functions are continuous, so we might want to check the endpoints. If we substitute -1 into this function, we get a y-coordinate of -1. And at +1, we'll get 15. So a continuous function must have to hit every intermediate value. So we want to make sure we cover our hypothesis and name the theorem as we write our argument. So we could say, since polynomial function f is continuous on this interval, as it would be continuous over all real numbers for that matter. So you could say over -infinity to infinity, but we only really care about this interval, so either one. And now I want to show that our target y-coordinate of 0 falls within this range. So I like to show where they occur as well. But for sure you want to show that 0 falls between these two values. So since our target y-coordinate falls between those two, then we know by the intermediate value theorem there exists at least one value c. And then we want to specify that we know that c has to fall between our x intervals. So we could use this c as an element of the interval from -1 to 1. Or you could use inequality symbols such that f of c is equal to 0. And you could do some other equivalent phrasing of that idea. All right, here we want to do mean value theorem in both of its forms. So the same function. So for derivatives, we want to find the instantaneous rate. Where is the instantaneous rate equivalent to the average rate? So remember, it requires differentiability. So we could say since polynomial function f, and now you don't necessarily have to write the entire argument here. It simply says find the values of c. So this could very likely be a multiple choice question on a test. Since polynomial function f is differentiable, so this is the entire argument here, over our interval, and it could go to the closed interval, by MVT, there is at least one value c. And you could say that c is between these two endpoints, such that, and now we need our instantaneous rate, that's f prime of c, to be equal to our average rate, that's the slope between the two endpoints. So the y-coordinate at f of 2 minus the y-coordinate at -2, all over the difference of our x-coordinate. So that's just our slope formula. Our derivative would be 6x plus 1, so we're going to put c into our function, 6c plus 1. F of 2, compute I think should be 10, and f of -2 looks like it will be a 6. So we want 6c. On the right hand side here you can see we have 4 over 4 is 1, and we're going to subtract 1 from it. So it looks like we would like c to be equal to 0. It is indeed between -2 and +2. So we're happy with that. All right, now we need to do our same function, but now we want to do MVT for integrals. So now we want to find out where does that average height occur. So think of making a rectangle that has the same area as the value of the integral. So we could say, and since polynomial function f, and now it will be integrable if it's continuous, we could say, since polynomial function f is continuous on -2 to 2 by MVT for definite integrals, there exists at least one C again between our two values, such that and now that could be at our endpoints as well, such that our average height, so we want, so that we're looking for a place where f of c is equal to our average function value or average height. So we could do a couple substitutions here if that's easier for you to remember. So if we put c into our function, that would be 3c squared plus c minus 4. And our average value of our function is our 1 minus b over a. So from -2 to +2, you might immediately just write that as 1/4 of our integral from -2 to 2 of our function. And if we work on that integral, we would do our antiderivative. So that would be x cubed plus 1/2 of x squared minus 4x, evaluated from -2 to +2. And if we substitute 2, we'll have an 8 plus 2 minus 8. Let me actually show you both of these. And then evaluated at -2, we would have a -8 plus 2 plus 8. And it looks like that's going to be 1/4 of 0. So we simply now need to find out what value of c. And let me save a step here. I see that this is factorable. 3c plus 4, c minus 1. So we will come up with two values, -4/3 and +1. And our interval went from -2 to +2. So both of those values are inside our integral. All right, find the average value. So we are simply looking for, not the x-coordinate where it exists, we're just looking for the 1 over b minus a times the integral. So our antiderivative would be x cubed plus x squared, evaluated from 0 to 3. And that would be a 27 plus 9. And of course, we don't have to write these 0 values. We'll make sure everybody realizes what we're coming up with there. So 1/3 of 36 should be 12 for our average height. So that's not the x-coordinate where it occurs, that's the average value of that function. Find the values of c that satisfy MVT. So this time we are looking for the x-coordinates where the average height occurs. So instead of writing the whole argument here, we'll just say we're looking for f of c that produces that average height. So if we get right to it, our function at c, and the width of our integral will be from 4 to 0, so 1/4 of. And we can quickly do an antiderivative here. This would be raise the exponent to a 2 and divide by it. And if you wish, you could factor that 2 out and then just evaluate x squared from 0 to 4, so that would be 16. So we would like our 4c to be equal to 8, so c should be 2. And again, it falls within our interval from 0 to 4. All right, I think here we would use our property of bringing the constant multiplier out of the function. And then we know that secant tangent is the derivative of tangent. Oops, let's try that again. That's the derivative of secant. So we would bring the 5 out, and then the integral, we'd do the antiderivative to get secant theta. And then we'd have to evaluate. And in my head, I'm never actually doing secant. I'm always thinking cosine and then doing its reciprocal. So at pi over 3, the cosine is 1/2, so its reciprocal would be 2. And at 2/3 pi, our cosine would be -1/2. And its reciprocal then would be a -2. So we would come up with here a value. I think we'll come up with 20. And now we want to go through our process of using an infinite Riemann sum to evaluate our integral. So remember our preliminary steps here. We need to find a delta x using b minus a over n. So the width of our interval is 3. So we'll use 3 over n. And our x sub I values, we'll use a plus I jumps of delta x. So here our a value is 0, and our delta x value we just did is 3 over n. So our x sub i's will be 3i over n. So that's what we're going to substitute into our function. So by definition, the integral from 0 to 3 of x squared minus 2x dx is equal to the limit as n goes to infinity of our sigma value as I goes from 1 to n. And then we need the height of each rectangle. That's our f of x sub I. So notice there are 2 x variables in our function. So we have to put our x sub I value into both of those. So we're going to have to take this value to the 3rd power. So we'll have a 27i cubed over n cubed. And then we're going to have minus 2 times that value. So we'll do a minus 6i over n. And then that's the f of x sub I is the height of each rectangle. So don't forget we need to multiply by delta x, the base of each rectangle. And our delta x here is 3 over n. And now we start cleaning it up, and then we'll split it into separate values using property of sigma and properties of limits. So you can distribute first if you wish. Several different order of operations that would work here. This is now over n to the 4th, and this would be an 18i over n squared. And we can now split this into our 2 different problems using our factoring, since we know that the I value is the only thing impacted by the sigma. And we know that the limit doesn't impact the constant, so if you want to do even more factoring, not the only way to do this, but of this first term, I could bring the 81 all the way out of the limit and the 1 over n to the 4th out of the sigma, and then I would just have I cubed And out of the second part, we could bring the 18 out here, the 1 over n squared out of the sigma, and then we would just have an I. And these are now formulas that we know. We can replace these with our formulas for the sum of the first n perfect cubes. We would replace this with n times n plus 1 over 2 quantity squared. And the sum of the first powers is n times quantity n plus 1 over 2. And then we can do some rewriting here. We can cancel one of these n's and just divide by n cubed. We can bring the 2, the 1/2 rather, out. Here we can cancel this n with one of those, and we can bring this 2 out. So we'll have 81 over 2 limit as n goes to infinity. And now I'm going to take the n plus 1. Oops, I'm jumping the gun here. Sorry, let's back up. I forgot that I had to square this value. So that's actually going to be an n squared that I just canceled. So can I fix this without adding another step? So this was going to be squared, and this was going to be a 4. So let's see if I can repair the damage. So I canceled n squared with the n to the 4th. So now I have just this binomial squared. So I think to not confuse anyone further, I will not do the division until the next step here. All right, and this one we're going to bring out the 1/2. And again, you could go ahead and do the division right away if you wish, but I'll save that for the next step to make sure I'm back on track after I made that error. Now we're taking a trinomial divided by a monomial, so we'll get 1 plus 2 over n plus 1 over n squared, and then we need parentheses. And here we have a binomial divided by a monomial. It becomes 1 plus 1 over n. And we do that division because now we can take the limit. We know that as n goes to infinity, these 3 fraction values will go to 0. So all we have left is the limit as n goes to infinity of 1. So of course that simply becomes 1. So we to make it clear that we're doing the limits here, you might write this step, that each of those limits becomes 1. So we have 81/4 minus 36/4, if you will. So we would have 45/4 or 11.25, as you prefer. I hope those are getting easier for us. All right, in number 7, evaluate the quantities from smallest to largest. You really don't even need to do close approximations, but you might convert these to numeric values if you wish. But you can see what's happening with the integral as we sweep across. From 1 through 6, we're accumulating more and more positive area. As we continue from 6 through 9, we would be losing more area. And the only other non-integral choice here is f prime of 5. Let's remember what f prime of 5 looks like. It looks like the slope of that tangent line. So you could estimate the slope of that tangent if you did a rise over run. Let me look at a couple points nearby, and it looks like it's in the neighborhood of -1. It looks to me like this area here would be closer to -2. So our integral from 6 to 9, I think, would be even smaller than e. So I would say b is the smallest value. And then E, I think all of the other values are going to be positive. We accumulate a lot more positive area here than we lose once we sweep through the negative. So I think might be easier for you to say, well, the largest value we're going to get is going to be from 0 to 6 because we haven't lost any of the area yet. And then as you think about 0 to 5, you haven't decreased any area yet. So I would say that when you go from 0 to 9, I would place that here. But you could go through and you could assign some specific values for each of these. So for example, if you thought this area was -2, and you could count up the squares in the positive area, and you could assign them each a value if you wish to be more precise. All right, let's take a look at each of these parts individually. If our function is never equal to 0, meaning our y-coordinates are never 0, does that mean that the integral will never be 0? Well, that would be false. We could do any odd function as an example. So for example, -π/2 to +π/2 of sine x dx we know produces 0. What do we know on a continuous interval here? This integral goes from a to c, and this one goes to b to c. Well, let's change that around. Let's keep the a to c, but then notice let's do the opposite limits here. So if we go from c to b here, what used to be negative, then we would do the opposite of the negative, so this would become positive. So by our properties of integrals, is this the same as the integral from a to b? So this one would be a true statement. And C says if the value of an integral is greater than or equal to 0, then are the y-coordinates over that entire interval greater than or equal to 0? No, it simply means we've got more positive area than negative area. So some of the y-coordinates could be below the axis. So that one could clearly be false. And this would be a good counterexample. In question 9, we've got functions for the velocity of both cars, and notice that over our interval from 1, 2 to 3 minutes, these are all going to be positive, so our net distance and total distance are the same. So to find where the cars are, we simply use our net change theorem. So the distance for car 1 after 1 minute would be the integral from 0 to 1 of 8t dt, and that would be 4t squared evaluated from 0 to 1, and that would give us a value of 4 feet. And our distance for car 2 at the same time would be the integral of 4t dt, and that would be 2t squared from 0 to 1. So it would be at 2 feet. And let me change that. I think my copy here isn't pasted in correctly. I think that was 4t cubed. So let me change right away. So 4t cubed, that would give us an antiderivative of t to the 4th from 0 to 1. So that would give us 1 foot. So after 1 minute, looks like car 1 is ahead. All right, and then we're going to repeat the process and evaluate from 0 to 2 minutes and then 0 to 3 minutes. I'm going to pause the video and just write that in since this is getting kind of long, and then we'll finish up. All right, so evaluating our antiderivatives, we see for question B that at 2 minutes, the cars have traveled equal distances, so then they are side by side. And when we integrate from 0 to 3, by this time car 2 has taken the lead. All right, part D says when do they travel at the same speed? So we don't want to mistake the example for B is when do they reach the same distance, not when are their velocities equal to each other. So for speed, we would do absolute value, but here we've got positives only. So we need not worry here about our signs. So set this to 0. And then let's factor a 4t, t squared minus 2. So at time equals 0, of course we knew their velocities were 0. And then at time and at times equal to plus or minus the square root of 2. And of course the negative square root of 2 is not helpful to us here. So at the square root of 2 minutes, their velocities or speeds are equal. Speed is simply absolute value of velocity, and that's going to come up here in question 10, again this absolute value question. So a velocity function could be positive or negative velocity. So displacement is the net change over time 0 to 8 of our velocity function. So we would have t cubed, raise the exponent to 2 and divide by it, so 6t squared from 0 to 8. Let me give you my tip here when I don't have a calculator here. I can see that something's going to cancel, so instead of figuring out what 8 to the third is, I'm going to write it as 8 times 64, so 8 times 8 squared. And this is minus 6 times 64. So without my calculator, I can see I've got two groups of 64. So 128 miles is our displacement for part A. For part B, however, the car actually traveled farther than 128 miles because part of the time it was traveling to the left. So we have to do absolute value function here. So now you would say, now what do I want to do without a calculator? And I don't want to. I could factor and find out where this is equal to 0, but I would definitely grab my calculator for part B and let it do the work. Otherwise, if I was stuck without a calculator, I would set this equal to 0, 3t squared minus 12t equals 0, and I would find out the places where it's equal to 0, and then I would split up my integral into 3 separate parts. So I would do the integral from 0 to 4 separately from the integral from 4 to 8, and one of those parts might be negative, so then I could switch the sign. So then I could put absolute values around them if I absolutely had to do this without a calculator. If it's in the calculator section, grab your calculator. That's what I just did a minute ago as I paused the video to do the other, think of the other question. So 192 miles is our total distance traveled. Sorry that video was kind of long. I hope you only watched the parts that you needed to. Feel free to fast forward through these homework videos.